Okay, before you ask me anything, let me write the matrix once again because I have lost mine. So let me write the matrix. Then I'm going to answer your questions one after another. First of all, quickly let me write the matrix was PQR with a column, extra column, that is D, and A, B, C, and this rows, the costs were 5, 3, 4, 2, 5, 1, 6, 2, 3, and the availabilities were
10, 21.
10, 21, 10, 20, 10.
10, 20, 10.
Yeah, 10, 20, 10, and BJs are 10, 10, 10, and this column is extra, so I'm putting the elements 0, 0, and the balance amount 10 is written over here, and the total summation AI and BJ is written. Tell me.
Sir, if suppose the penalty of one row and one column is same, so we can consider any or any of that.
I'm going to show, I'm going to discuss everything, and that's why I have arranged this particular class. Every situation you are going to get in this particular problem, the situations which have not been discussed earlier. So one after another. So what is this column actually, D? This column is actually known as a dummy column. It's a dummy column. What is the relevance of this dummy column? Dummy column has no physical significance. Dummy column has no physical significance. Actually, we have to solve it. We have to do the mathematics with this transportation table, and for enabling ourselves to solve this particular problem using mathematical knowledge, then we have to introduce this as a virtual column where we can say, if somebody or someone is asking you that these factories can produce this much amount of items, you have got in total 40 items altogether, total capacity 40, and your demands of the factories are 10, 10, 10, that is 30. Then what you are going to do with your remaining 10 items? What you are, will you destroy it, or will you keep it in the factory? You will keep it aside. What you are going to do with your this extra amount of items? Then actually,
sir, a few students are there in the waiting room, sir.
Oh, just a
Anik
minute.
has texted.
Yeah, okay. But my waiting room is not. I have not. Just a minute. Okay. Yeah. Okay. I have actually allowed them. Just a minute. So actually, if you are going to ask me that what you are going to do, sir, with this extra amount of item, then I must say that, yeah, okay, we are not going to for the sake of the calculation, we are not going to keep these items in the factory. We are going to send them somewhere in somewhere in some destinations where this destination is actually not existing, but we'll think that this, if they exist, then I am going to send these items to that particular destination. Okay. Or in other words, from a more practical point of view, we can say that, sir, actually I'm going to keep these items in the factory for their use in future. So these items, this extra amount of items has become our inventory. So we are going to keep it in the factory, and we are going to find a destination, and we are going to send those items there. But at present, the destination is not available to me, and therefore I'm going to actually think of a virtual destination which is not practically existing, which can take my remaining 10 items in it. And therefore this imaginary destination is called the dummy destination or dummy column. And if you are talking about a dummy row, that means you are actually introducing a dummy factory, that you are going to, that dummy factory, you are going to imagine that this factory is actually going to produce the remaining amount of items. Then at present, it is not happening. It is for our future course. So therefore, it is actually dummy. And since at present, these dummy columns or dummy rows are not existing, so there is no cost associated with them. And so we have put 0, 0, 0 in the dummy row. So therefore we have written 0, 0, 0 in this dummy column. Okay, so now my problem has become balanced. You are now eligible to apply VAM method over here, or any method of transportation problem. So now you apply VAM method. Now you apply VAM method. Okay, so first of all, for solving VAM, we actually calculate the penalties. Now,
Sir Akash.
Akash Gupta has asked me something, so I'm going to give that answer right now. So this is
So we can take any row or column in that case.
I'm coming to that point. Let me show it first of all. Let me show it to others. Okay, the others will not understand. Yes, your answer is right. Your point is right. You are going to we are going to take any row or any column, any column. That is the arbitrary choice. So I'm going to show it mathematically to others. Okay, so in this, to calculate the penalties, as we know, first of all, this is the minimum element. 0 is the minimum element in each row. Here 0 is the minimum and next minimum is 3. So your penalty is 3. Here 0 is the minimum and next minimum is 1. Your penalty is 1. Here 0 is the minimum and next minimum is 2. So your penalty is 2. Okay. Now for calculating penalties of these columns, 2 is the minimum and next minimum is 5. So 3 is the penalty. Here 2 is the minimum and next minimum is 3. So 1 is the penalty. Here 1 is the minimum and next minimum is 3. So 2 is the penalty. And here 0 is the minimum and next minimum is 0. So the penalty is 0. Now what Akash was saying, that he has got, what we actually do in VAM, we analyze all the penalties together. We analyze, yeah, tell me.
Sir, in under BJ, the penalty is 3 to 1.
Why?
It will be 3 to 1.
No, 3, 1, 2.
Because 3, 1, 2. How, sir? 2
is the minimum.
Yeah.
What is the next minimum? 3.
Yeah, 3 is the next minimum.
So we take the positive difference of these two. 3 minus 2, that is 1.
Okay, okay, sir. Okay, sir.
Yeah. Okay. So the Akash was saying that we analyzed all the penalties together and we find the maximum penalty. So Akash was saying we have got. Akash was actually pointing to that. He was.
Sir, if we got a maximum penalty, then we will go according to this row, right? We can
go with respect to, in this particular situation, we can go with respect to this row or that column. So you can select this column or that row. So I am going to select this time. I am going to select this column because it is my arbitrary choice. I am going to put an arrowhead like this. This arrowhead is actually.
Sir, one question, sir.
Yes.
Sir, as we can see, the row and column, there is both a 3-3 situation. So, sir, we can go with anyone, right?
Yes, anyone.
We go row or column.
Yes, anyone. You can select these two also. You can select this penalty also. I do not have any problem. But I am, for the time being, without any loss of generality, I'm selecting this. Actually, the rule is that if there is a tie, then you have to make arbitrary choice. There is no mathematics. Your choice is arbitrary. So here I actually, in the previous two problems, I actually always selected rows. Now, since the tie has come, this time I'm going to select the columns. It is my choice. So this arrowhead actually indicates that somewhere in this column, in the least cost cell, we are going to put the allocation. Now the least cost cell is this one. This is the least cost cell. This is the least cost cell 2. And therefore I'm going to put an allocation in this particular cell. And this allocation can be 10 or 20, but we know that we always select the minimum of AI, bj. Minimum of AI, bj is allocated in the least cost cell with maximum penalty, with max penalty. And so therefore I'm going to allocate 10 over here. I'm going to put 10 over here, and I'm going to erase this 10, and the balance is 10 is written in this manner. Now this job, purpose of this particular column is done, because requirement.
So we can consider this column as I mean, not valid, right?
No, not valid. No, it is not actually valid. No, this is, the term is wrong. Don't say not valid. Requirement of this column is exhausted. The column has requirement of 10 items. It has got 10 items. Okay, so the column will not be further taken into consideration for our further calculations.
Yes, sir.
Okay, so rest is Q, R, and D. Q, R, and D, and my rows remain same, A, B, and C. And the items are 3, 4, 0. Then we have 5, 1, 0. And then we have 2, 3, and 0. And my availabilities are now 10, 10, and 10. And my requirements are now 10, 10, and 10. Here I am going to calculate the penalties once again. Now, this.
Sir, I have a question regarding this.
Yes, yes.
Sir, actually, what we done in our previous course, I mean BBA, that there is our teacher said that actually somebody did that. I mean separately, or it can be done with this also. I mean, after using comma, we can calculate another one. Is both right?
Now, have you passed BBA from McCouth?
No, sir.
Oh, from other university. Okay. Now, you can do the calculation in a single table, or you can separately do it. You can separately make the tables, whatever you think convenient. Because if I make the same, if I do the calculations in the same table, then if you talk about me, then actually it becomes tedious and I cannot manage with the numbers. So actually I try to avoid it. So it is just my choice to make separate tables, but it is not a universal choice. Okay, so you can make it in a single table. Others, please keep on doing the problem, because if you get the answer, the cost matrix, solution matrix before me, you can say, and then I'm going to write the cost matrix directly. Okay, so you have got this 0. This is the minimum, and next minimum is 3. So the penalty is 3, and here new minimum element is 0, and next minimum is 1. So penalty is 1. 0 is the minimum element. Next minimum is 2. So penalty is 2. And here the minimum element is now 2. Next minimum is 3. So it is penalty is 1. Minimum element is 1. Next minimum is 3. Penalty is 2. And here penalty is 0. So now we have a single choice. We have got our maximum penalty, which is 3, and we are going to allocate somewhere in this row in the least cost cell. But the least cost cell in this particular matrix, the least cost cell is which one? 0. The dummy cell, dummy column containing this cell is the least cost cell. So my allocation will be here in this dummy column. Virtually I'm going to send items to this column. It's just for the sake of mathematics. Now tell me.
Sir, at this time of choosing this penalty, I mean, higher value we have to take, right? I mean, 3, 1, 2 here in AI
in
and
columns,
in B,
and in below we have 1, 2, 0. So you can
2, 0. I mean, sir, in these values we have to take the higher one, right?
Out of all the penalties, you have to take the highest one. If there is a tie, then we have.
I see.
Yeah, if there is a
if
tie,
there is tie, then I can take whatever I would like to.
Yes, yes, yes.
Okay. In this case, allocation will be in lowest, but in the case of choosing the penalty, we have to take the higher value.
Yeah, allocation will be lowest, but penalty will be highest.
Okay. Understood. Thank you.
This actually, this particular thing, why penalty is highest and allocation is lowest, it has a mathematical reason, but I'm not going to discuss because it will be kill the time. But later in some some other class, I'm going to tell you why it is higher and this is lower.
Sir, I have a question, sir.
Yes.
Sir, as we can see, according to which value just we find, it's 3 is the highest one, right?
Yes.
And so, sir, according to this, AI and VJ is now both at 10, 10. So, sir, is it both row or column going to be existed?
Exactly. I'm going to tell you the least cost cell is 0. So in this particular point here, the actually this demand is 10 and here the availability is also 10 because both of them are same. So I am going to put 10 over here. This is the allocation and I am going to cancel both the 10s. Not only this, from our subsequent calculation, I am going to eliminate this column as well as this row because their purpose is over. The row could give 10 items. It has given 10 items. The column could take 10 items. It has taken 10 items. So both of them will be simultaneously crossed out. Now we are left with this particular matrix QR and BC. QR and BC. Yes.
Sir,
Tell me.
Actually, we always minus from highest to lowest.
I didn't get your point. What highest to lowest you are talking about?
Sir, I mean, suppose we have 2 column right now, Q and R, right? So suppose we have to, suppose there is an example, Q is 5 and R is 1. So we have to minus from 5 to 1, right?
Yeah, actually we actually, the formula is that we among all the elements present in a particular row, you have to select the element which is minimum and you keep it in your left hand. Then consider the remaining elements in that row. Choose the minimum, keep it on your right hand and take the difference. So the difference can be negative or positive, but you have to consider the positive difference. So if your minimum is 1 and next minimum is 2, do not consider 1 minus 2, that is minus 1. Consider 2 minus 1, that is 1. So we have got this penalty.
60 will be the answer.
Yes, tell me.
60 answer.
I don't know.
So 50 is coming.
50, yes, 50.
Cost.
Yes. Transportation cost is 50. So okay, fine. Yes, 50. So you see.
50, sir.
Yes. So all of you have got answer.
Yes, sir.
So I have got
50.
Okay, let me finish.
I also, sir. 50.
Okay, so the penalties now is 4 and here the penalty is 1 and here penalties are, let me quickly solve it. And this is 3 and that is 2. Now the maximum penalty is this one now. 4. And least cost cell is this one, that is 10. And I am going to cancel both of them. And this row will be cancelled, this column will be cancelled. And lastly, we are left with this particular matrix, that is Q, only Q and C, nothing else. Single cell, Q and C, and availability is 10 and requirement is 10. So you don't have to calculate penalties and etc. because there is no meaning of calculation of penalties because there are not only one item, not more than one items. So only this cell is remaining and therefore you are going to, no other option out, but you are going to allocate this amount 10 over here and you are going to strike it out. So we have got allocations. We have got allocations in which particular cell. We are going to write the matrix, right? We are going to write the matrix now, a solution matrix. So we have got the allocations where, let me write it. BP, in the cell BP, we have got allocations. So we got allocations in the cell BP. Then we have got allocations in the cell AD, and we have got allocations in the cell BR and CQ. BR and CQ, isn't it? BR and CQ.
BR and CQ.
BR and CQ. So I'm going to write the matrix once again. So the matrix is the solution matrix is now P, Q, R and D. because you are going to put the dummy, because dummy is now a part of your problem. Do not omit dummy. Don't think that dummy should not be there, because dummy was originally not there. You were able to solve this transportation problem because of this introduction of dummy column. So dummy will now remain in your calculations, further calculations. So we have got this solution matrix. Let me quickly write 5, 3, 4, 0. Don't have to write availability and requirements because their job is done. 2, 5, 1 and 0. And we got 6, 2, 3 and 0. And in the cell BP, the allocation is, what are the allocations? 10.
So 2 to the power 10.
Okay. So,
I'm telling
2 into 10, sir.
PB, 2 to
10.
the power 10.
AD is
In the
10.
dummy column, it is 10 and 1 is 10, 1 to the power 10.
Sir,
1
sir,
10.
it is not. Sir, it
And
is not
2
to the power,
10.
sir. Actually, it is, I think, 2 into 10, right?
No.
Yes, yes,
actually,
yes.
not
Yes,
power.
210.
He is actually not telling power. He knows it.
I'm not telling power.
He is actually, Akash, you have to be very much careful. You are in the classroom, so it is no problem. I can understand
Yes,
what you
I
mean
can
to
understand.
say. But if you are sitting in front of an interviewer, and if you say to the power, then
I know such wrong.
there is wrong.
That means, sir, another thing.
Yeah, actually, fine. So these are the allocations. So transportation cost is calculated as rupees 0 into 10 plus rupees 10 into 2 plus rupees 1 into 10 and plus 2 into 10. So we got 20 plus 10 is 30 plus 20, that is 50. So rupees 50 is my transportation cost by VEM, but we do not know whether it is optimal or not. So we have to check whether the problem is optimal or not. Before you go to check for optimality, I am going to talk about generalized version now, generalized methodology. That is new, which has not been discussed earlier. Generalized methodology. Generalized methodology simply says that before you apply MODI, check whether the solution is non-degenerate. I have not told you this particular thing earlier intentionally, because in the earlier problems the thing was non-degenerate. I didn't have the problem, so if I said to you, I wouldn't have been able to show you by an example. So I didn't tell you about this. So first of all, you have to check whether the solution is non-degenerate. If not, we have to make it non-degenerate somehow. We have to make it non-degenerate. If it is yes, then we can proceed with our usual methodology. So first of all, you have to check. This point is very important. First of all, you have to check whether the solution is non-degenerate or not. Now you see how many rows are there. Number of rows in this particular calculation is 3, and number of column is equal to 4. So actually we want 4 plus 3 minus 1, that is 6 allocations. 6 allocations. But we have got how many allocations? 4 allocations. 4 allocations. So the problem is what is the problem? It is a degenerate problem.
Degenerate.
It is a degenerate problem. It is a degenerate problem. So therefore,
our
now
target is to,
yes,
sir, our target is to our target is to just make it non-degenerate, right?
Yeah, make it non-degenerate. Our target is to make it non-degenerate. Now I'm going to tell you how to make this particular matrix non-degenerate. There are some rules. I actually uploaded a note in the Google Classroom. There you can find something is written in the form of delta. Probably you have not understood what delta is actually meant for. So I'm going to tell you what is the meaning of this delta. Some number delta kind of thing was written over here.
Okay.
So now you see, what you can do is that you are going to, first of all, you are going to, out of these non-zero elements, only consider these non-zero elements. In these non-zero elements, some cells have got allocations, some cells have got allocations, and some cells have not got allocations. From the cells which have got allocations, we have no problem with them. But the cells who has got allocations, the cells who have got allocations, for those cells, no, actually I mean to say the cells who have got allocations, we have to keep it aside. But the cells who have not got allocations, from those cells, non-zero elements I'm talking about, choose the cell which contains the minimum element. Say for example, all these particular, I am moving my cursor together, all these elements are actually non-zero, and from out of these non-zero elements, this element, and this element, they have got allocations. So you keep them aside, their purpose is done. But if you consider the other elements, say 5, 3, 4, 5, 6, 3, all these 6 elements are unallocated, and therefore we are going to put allocations over there. Put allocations over there. Where do I put the allocations? First of all, we shall select all these, we shall consider all these unallocated cells, and we shall consider that particular cell which contains the minimum element. Say, so we have actually identified two such cells. One is 3 and another is 3. So in a transportation problem, if there is a tie anywhere, then we have to make the arbitrary choice. So out of these 2 3s, I am going to put, out of these 2 3s, I am going to select any 3, say for this one, and I am going to allocate an amount delta. What is delta? I'm coming to this particular point. Okay, this is, I'm going to put delta over here. So you can put it as delta. Delta amount of allocations have to be made in this particular least cost cell. Now this particular cell, after getting delta allocations, has become allocated. Now you have got, out of these non-zero allocations, you have got 1, 2, 3, 4 allocations. Previously it was only 3. Now you have got 4 allocations, and total number of allocation is now how much? 5. We need 1 more allocations. So again, I am going to choose.
Sir,
yes, tell me.
Sir, in this case that you are keeping the delta, na? So sir, even is this type of question will come, may come in our assignment, like to make it non-degenerate?
Don't think about
no,
that.
Sir, if it will come, no, sir, the thing is that my question is, sir, if it will come, then we can draw again a separate table, na, of which are not having that allocations. Like so, you are telling that we can draw another table like to 5, 3, 4. 6,
no, don't draw another table, separate table, because you are going to apply the Modi method to this particular solution matrix, not in the separate table. Okay. Modi method will be applied on this, but we are unable to apply the Modi method right now because the number of allocations is less than, is not 6, it is less
than 6, that is 4.
Now after putting allocations delta, it has become, total allocation has now become 5, which is again 1 less than the desired amount. So to allocate further, we are going to select remaining 4 non-zero elements. We are going to select remaining 4 non-zero elements, 5, 4, 3, and 6. And out of these non-zero elements, this is the minimum now. So I'm going to allocate delta prime over here, delta prime. So you now you count the allocations, 1, 2, 3, 4, 5, 6, 6 allocations, and my desired allocation is 6. So now the problem has become non-degenerate. Okay, so your question is that what is delta actually? Delta is a number. Delta is an arbitrary number. Delta is an arbitrary abstract number, remember, abstract number, which is making the solution, non-degenerate, and delta or delta prime, whatever, you say, has the following properties. These properties actually, you have to digest it. These properties actually have been imposed on deltas. Otherwise, you will not be able to. Otherwise, if I do not impose these properties, if you can ask me this question, sorry, what is this properties? What are they talking about these properties? If we do not impose these properties on deltas, then something will not happen. What is that? If you do not consider these deltas, delta and delta prime, then we have actually got 4 allocations, 1, 2, 3, and 4. Transportation cost is actually 50. But if delta is a delta and delta prime, these are 2 new allocations. Actually, what does it mean? It means that my new transportation cost is just a minute. Tell me the values once again. What was the cost? 0 into 10, 10 into 2. Okay, let me write it. 0 into 10.
0, 10.
Plus 10 into 10.
210, 110.
110 and?
Again 210.
Again 210. And then we have to write 3 into delta. And again you have to write 3 into delta prime. So if delta and delta prime, these delta and delta prime, these are actually numbers. These are actually some numbers which are positive numbers. Delta is a positive number. Delta prime is a positive number. So you may ask me this question that you are introducing an allocation, an extra allocation to the cell, delta and delta prime. Will it change the transportation cost? So that I have to consider this delta and delta primes in such a manner. I have to consider this delta in such a manner so that it satisfies the following properties. What are these properties? If we multiply this delta by a cost, answer should be 0. I have imposed the properties. Just like we say to the children, don't go there alone. Or we say that do not talk in the classroom. Or we say that do not sleep at the time of having your lunch. Don't lie down and have your lunch. These are the rules we actually set. So here also we have set a rule for delta, that if delta, do not be too much bothered about delta, because delta is such kind of number. If it gets multiplied by Cij, any cost, the answer is 0. Another property is if we add any number to delta, or if we subtract delta from any number, then the number doesn't change. The second property. And third property we have imposed, delta plus delta is actually delta. It's not 2 delta. And the last property that we have selected is delta minus delta, that is 0. These are you can say that 4 axioms. These are axioms. Do not get confused about the nature of delta. Delta is a kind of child who has been instructed to do something and not to do something. So that my transportation cost is not affected. So that I get here 0 and here 0. And you will see that my transportation cost remains ₹50 only. So you don't have to bother about your transportation cost. Delta is not actually affecting your transportation cost. Delta is making the degenerate solution as a non-degenerate one, so that we can apply the Modi method. So the point which I didn't discuss, I didn't tell you specifically in the earlier class, the point is that important point is that apply Modi only when the solution is non-degenerate. This is the actual point I want to make. And for this, I am introducing delta. Now, I am going to write my Cij. Now I am going to apply the Modi method here. Modi method. So now someone please tell me that what is the Cij matrix. You have to, first of all, you tell me the costs. Sorry, don't tell me the cost. You tell me which cells were allocated cells with respect to after introduction of delta. Tell me. BP. BP was allocated. Then?
Yes, to AQ.
AQ.
Sir, CQ.
Okay.
Sir, BR.
AD.
Okay.
And CR.
Okay.
The CR, BR, both.
Okay. This is all right? Okay. And what are the elements, remaining elements? Tell me.
So, I mean,
Values.
5 AP 5.
AP is 5.
Sir, AR4.
AR4.
BQ5.
BQ5.
Sir, CP6.
Okay.
And both are 0. Dummy column 0.
Okay. So this is my Cij unallocated. This is my Cij unallocated. We are going to now, this is another important point. We did a mistake in one of my classes. For always remember, for allocated cells, we are going to write our equations of the form ui plus vj is equal to Cij. So my allocations are actually u1 plus v2. I mean, for this cell u1 plus v2, this is actually C12. Then we got this cell. This cell. This is u1 plus v4, that is equal to C14, means this one. And we have u2 plus v1, that is C21, that is this one. And we have got u2 plus v3, that is C23, that is for this cell. Then we have got u3 plus v2 is equal to C32, that is for this cell. And u3 plus v3 is equal to C33, that is for this cell. And what are these values? Tell me.
Sir.
C12.
Sir.
Bolo.
Sir, आगे तो हमें calculate करते for unallocated cells.
No. Actually, we calculate.
allocated cells hobe.
Or actually, we calculate the numbers for allocated cells, but we will prepare the matrix for unallocated cells.
Okay.
The matrix will be unallocated, but that is the problem. That is the problem we actually made in the second session of the first lecture of transportation problem, which I actually by mistake did this, and some students pointed me out. And now the class is going to end very soon. You quickly write these numbers, quickly write these figures, and find u and vj. And in the third session, we are going to join and we are going to make the ui plus vj unallocated cells. So you try to do it by yourself.